ಯಾರು ಮಾತಾಡ್ತಿರೋದು? ಯಾರು ಮಾತಾಡ್ತಿರೋದು? ಹೇಳಿ, ಅವ್ರು ಕ್ಲಾಸ್ ನಡೀತಾ ಇದೆ, ಆ ಕಡೆ ಹೋಗಿ. ಹಾ, ಇರ್ಲಿ. Pawan, unmute yourself and tell me the screen and sound is visible, audible.
Sir,
Hello?
and audible, sir. Yes, sir, it is visible.
Hello? Pawan?
Yes, sir.
Yes, sir. Screen is visible, sir.
Hello, anyone unmute yourself and tell me the screen is visible.
Yes, sir.
Pawan?
Yes, sir, it is visible.
Hello?
Yes, sir, visible.
Hello?
Yes, sir.
Screen is visible, sir.
Renil, unmute yourself and tell me visible and audible.
Yes, sir.
Hello?
Yes, sir, it's
Renil,
visible, sir.
unmute yourself.
Yes, sir.
Hello? Renil?
Yes, sir, it is visible.
Renil, unmute yourself and tell me.
Yes, sir.
Hello? Pawan? ಹಾ, ಓಕೆ. ಅಲ್ಲ, ಈಗ ಸೌಂಡು ಮತ್ತೆ ಸ್ಕ್ರೀನ್ ಕಾಣಿಸ್ತಾ ಇದೆಯಲ್ಲ? ಹೌದಾ, ನೀವು ಮಾತಾಡೋದು ಕೇಳಿಸ್ತಾ ಇಲ್ಲ. ಹೌದಾ, ಸರಿ, ಕ್ಲಾಸ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಲಾ? ಓಕೆ. Last class we discussed about the measurement of effective diameter, means the major diameter and minor diameter of the thread. So this is one method where you can use plaster of Paris, keep the nut in between the two blocks and fill the nut with the plaster of Paris. And after dry, remove the mold casting. And from that also you can measure major diameter, minor diameter, flange angle, thread angle, addendum, dedendum, and all the components or elements of the thread. As I told you earlier, so we have two methods. One is two-wire method, other one is three-wire method. You have this experiment in the metrology lab, the measurement of elements of the thread by using three-wire method. So this is a very, very important. All of you, please write down the question. Please, all of you write down the question. Explain briefly with the need sketch. Explain briefly with need sketch the elements of thread measurement, elements of the thread, the elements of the thread by using three-wire method. Using three-wire method. All of you mark, very, very important. You can expect this question in the examination. You can expect this question in the examination. Say, all of you observe here. Say, wire means it's a small shaft of length 20 millimeter, of diameter 2.5 millimeter. See, all of you observe here. Here you have two wires, another one on the opposite side. Wire means it's a small shaft of diameter 2 or 2.5 millimeter. You already seen the micrometer. You can fix this wire where you have one wire, you can fix on the stationary anvil of the micrometer, and the other one you can fix on the movable anvil of the micrometer and adjust the micrometer by turning the thimble in clockwise direction. See that the two wires can sit in the profile of the thread like this. Profile of the thread like this. If you adjust one wire, single wire or two wire, automatically the other wire will come to the opposite side. Other wire automatically come to the opposite side and sit in the thread profile. After fixing this, and how do you measure the effective diameter? That is major diameter, minor diameter, addendum, dedendum, and the angle of the thread, that is theta. So for this, first draw the diagram like this. The H indicates a major, half of the major diameter, and D is the major diameter. So D, uppercase letter D indicates the major diameter, and M is the diameter over the anvil, over the wire, and complete the triangle like this, A, B, C, D. A, B, C, D. And after that, put a vertical line which touches the pitch of the thread, and that is theta by 2, half of the thread angle. And theta is the thread angle, and P is the pitch. P is the pitch, and E is the effective diameter. E is the effective diameter. Above the axis is addendum, below the axis is dedendum. So like this, complete the diagram. First, write the thread profile like this and show the two wire in the bottom, single wire on the top, and with these two wires are available in the form of anvils you can fix on the anvil of the micrometer. Then turn the thimble in clockwise direction so that single wire or two wire which fit on the profile of the thread, automatically the opposite side single wire or two wire will make in contact with the thread profile. So this is the experiment. Then note down the major diameter, minor diameter, pitch, angle of the thread, and the remaining all, that is a measurement that is from the bottom of the thread that you can measure. The examination point of view, this is very important, and you can expect this question in the examination. Maybe two wire method or three wire method. Everything is same. In case of two wire, you have two anvils, two shafts, or two wires. But in case of three wire, there will be three wires are present. So you can use a three wire method or two wire method. Say you have one more question in the examination. Best wire size. There will be a question. Please, all of you write down. How do you select the best wire size? Please, all of you write down the question. How do you select the best wire size for the measurement of thread? Say, in this question, you have to write the three wire method is the best wire because you have more elements can be measured in a single set of experiment. You can measure more elements by using three wire method. So for that reason, in the examination, you write the three wire method is the best method for measurement of thread profile in the metrology laboratory. Once again, first write the thread profile like this, then show the letter E that indicates the axis that indicates the effective diameter, which is used for fixing of bolt in the internal, for in case of internal thread. If it is external thread, fixing of nut on the bolt. Then in three wire method, two anvils are available. All of you seen the micrometer. You can fix the two wire on the stationary side or movable side of the micrometer, and the other one maybe single or two wire on the other side. Then fix the thread component in the vise and fix the micrometer along with the three wire and turn the thimble so that two wire on the other side, opposite to the other side, diametrically opposite to the other side, single wire can be accommodated on the profile of the thread. Then you measure the major diameter, minor diameter, pitch of the thread by measuring the effective diameter and complete the experiment by using the diagram like this and complete the diagram A, B, C, D. This is required for derivation. All of you observe here, this is the small derivation. M is the diameter over the wires, E is the effective diameter, D is the diameter of the wires. Then for metric thread, you have the equation M equal to diameter over the wires. So that can be calculated by using the equation E equal to D minus 0.6495 pitch. Theta equal to 60 degree. The thread angle is 60 degree. Then you can calculate the M by substituting the values D and small d and the pitch of the thread in the equation. You will get M. That is the diameter over the wires. Next, as I told you, you have to write the expression for the best wire size. That is write the thread profile like this, and this is the pitch line, this is the effective diameter, pitch divided by 2 and pitch divided by 4, and complete the triangle OAP. This is the right angle triangle, and the angle theta by 2, half thread angle. Theta is the thread angle and radius of the wire. That's the best wire size for measurement of effective diameter, major diameter, minor diameter, pitch, and the angle of the thread. Next, come to the point. There will be two methods are available for the measurement of major diameter, minor diameter, pitch of the thread, angle of the thread, addendum and dedendum. Remember like this, the portion above the axis of the thread always that is addendum. The portion below the axis of the thread always that is dedendum, and angle of the thread. Remember 5 elements: major diameter, minor diameter, pitch of the thread, angle of the thread, and addendum, dedendum. So you have 6 elements in the examination. You can write any 5 elements of the thread, then you will get full marks. Now come to the point. This is the tool maker's microscope. Tool maker's microscope. All of you, please write down the question. Second question in the module 3, there will be 2 questions. One is explain briefly 2-wire method or 3-wire method for the measurement of thread profile. In the second question, always that is tool maker's microscope or profile projector. So in our metrology laboratory, we have tool maker's microscope as well as profile projector. We can conduct the experiment using tool maker's microscope as well as the profile projector for measurement of major diameter, minor diameter, pitch, angle of the thread, addendum, dedendum. Like this, you can measure the elements of the thread by using tool maker's microscope and profile projector. Next, come to the point. All of you observe here, and all of you please write down the question. Please write down the question. Explain briefly. Explain briefly with a neat sketch explain briefly with neat sketch the tool maker's microscope. Tool maker's microscope. Put a question mark. Put a question mark. And list the applications. List the applications and limitations. I repeat, please write down the question. Explain briefly with a neat sketch tool maker's microscope. Question mark. List the applications and limitations. say all of you see this diagram. This is a very important for the examination. You can expect this question in the examination. Here, this tool maker's microscope looks like a regular microscope, but the thing is, a small bolt of V thread of thread of the angle is 60 degree. Place it on the table. Hello, sir. Class alladine. Okay. So place it on the table. See the small bolt. All of you seen the 2-inch or 3-inch bolt of diameter 10 millimeter or 8 millimeter. Place it on the table. And after that, what are the things present here? First one, the lamp which produces the light rays which passes through the collimator lens and the lens, and the rays coming from the mirror which hits the mirror, which is making an angle 45 degree. The mirror is placed at an angle of 45 degree and passes through the intersecting the workpiece. Remember, place the bolt on the table. This is the transparent table. Light rays passes through the workpiece, intersecting the workpiece, and one more mirror is present here, which reflects the rays into the eyepiece. Here, you can adjust the table in such a way that you can measure the major diameter, minor diameter, pitch of the thread, and angle of the thread. That is possible. There will be a crosswire present in the eyepiece. You can adjust the crosswire to measure the major diameter, minor diameter, pitch of the thread, and angle of the thread, and the addendum and the dedendum of the thread. That is, addendum means the portion above the axis of the thread, and that is called addendum. The portion below the axis of the thread, that is a dedendum, that can be measured by moving the micrometer provided in the table. See, all of you observe here. This one is the micrometer symbol. You can turn clockwise direction or anti-clockwise direction so that you can measure the distance between the 2 quick points is the pitch of the thread and effective diameter, the 2 peak points of the thread in opposite direction, that is major diameter, and the portion of the thread below the upper portion, that is minor diameter, and effective diameter. In between the crest of the thread, there will be a diameter, that is the pitch diameter, and addendum, dedendum, thread angle, and the flange, thread angle, and the flank surface. That can be measured using the tool maker's microscope. This is the principle of operation of tool maker's microscope. Once again, what are the things present here? First one, this is the cast iron base, and also you have a hollow base that is also made of cast iron, and there will be a lamp which produces the light which passes through the collimator lens and the lens, and which make the light rays which incident on the mirror. The mirror is placed at 45 degrees so that all the rays passes through the table of the tool maker's microscope. Then place the bolt with the V thread of 60 degree on the table, and the table is the transparent one which is made of glass sheet. Then the light coming from the lamp which intersects the workpiece passes through the eyepiece and there will be a crosswire in the eyepiece. Then after adjusting the light rays by seeing in the eyepiece, you can adjust the crosswire to read the pitch. Pitch means definition of the pitch is two peak points of the thread is called pitch. Adjust the crosswire to first pitch, first edge of the pitch, adjust that and see, note down the reading. Then there will be a micrometer on the table. Turn that, the crosswire moves and coincides with the pitch of the next upper portion or the edge. That is the pitch of the thread. Then if you want to measure the profile of the thread, then adjust the micrometer crosswire to read the thread diameter. That is the external maximum diameter, that is the maximum diameter of the thread, and the minor diameter of the thread, and angle of the thread addendum can be measured by using tool maker's microscope. This is the principle of operation of tool maker's microscope. So all of you observe here, this is the photograph of the tool maker's microscope. Say you have 2 micrometer anvils, 2 micrometer, you have 2 micrometers, and this is the thimble for the movement of y-axis and movement in the x-axis. You can turn the thimble clockwise direction and anti-clockwise direction. There will be a hollow base in the bottom. And this is the column of the tool maker's microscope, and this is the eyepiece. And all of you observe here, this is the transparent glass table. Glass table. On this, place the bolt. Place the bolt of external thread of angle 60 degree. Of angle 60 degree. Place it on the table. Then observe the profile of the thread by using eyepiece of the tool maker's microscope and adjust. For example, if you want to measure the pitch of the thread, which is nothing but the 2 peak points of the thread. First, adjust the first peak point of the crosswire and note down the reading. Then move the crosswire for the next peak point immediate to the first one. Note down the reading. The distance between the 2 peak points is the pitch of the thread. That is pitch of the thread. All of you observe here, so the same type of tool maker's microscope we have in our metrology lab. You can measure the thread profile by using tool maker's microscope. All of you see here, this is the tool maker's microscope. This is the hollow base made of cast iron. Above that, there will be a table. In the center, there will be a lens and mirror system is there. The light is coming from the lamp, which is intersects the workpiece and passes through the eyepiece. You can observe the thread profile in the eyepiece. Adjust the crosswire to read the elements of the thread by using tool maker's microscope. Tool maker's microscope. All of you mark it. This is a very important. The examination point of view, this is very important, and you can expect this question this time. All of you, please write down the question. Explain briefly with the neat sketch. Explain briefly with a neat sketch the tool maker's microscope. Tool maker's microscope. Put a question mark and continue the question. Least list the applications and limitations. What are the applications you can write here? So that is, the instrument is very, very easy. Anybody can measure the thread profile is possible. The first advantage. Second advantage, you have accurate elements of the thread. Next, the process, the measurement is very, very easy, and the answers are very, very precise and accurate. Next, there will be no chance of movement of thread going outside or inside the measuring area. And here, the parallax effect is less. Parallax effect is less. Like that, write down 5 applications. At the end of the online class, I will give you 8 or 10 applications. For all the questions, you write these 10 applications in the examination. Remember, 10 applications. In that, you have to write minimum 5 in the examination. I will give you in the end of this online class, that is at the end of this course. For any question where you have the question on application, you write the same thing in the examination. And the limitations. So limitations, the instrument is a very precise one, robust, and you cannot use a big size of work. That's one limitation. And there will be chances of misplace of bolt or thread on the table, and the movement of the eyepiece is very slow. Like that, you can write number of limitations of the instrument. Like this. And this is the last portion of thread profile, measurement of thread profile. Now I'll stop at this stage, and all of you, please write down your name and USN in the chat box. This is the last portion in the first portion of module 3, that is measurement of screw thread or thread profile. All of you, please write down your name and USN in the chat box. Next class, I will start the gear measurement. ಒಂದು 5 ನಿಮಿಷ